Okay, the first theorem is the extreme value theorem, or the EVT. Let f of x be continuous over the closed interval between a and b. F of x attains a max and min value over this interval. Alright, now let's look at a graphical representation. Here you can see that we have the function f of x on the closed continuous interval a and b. Because it's continuous, we necessarily have a maximum and minimum y value on this interval.
Now let's look at an example. If f of x is x cubed and it's continuous over the closed interval 0, 10, by the EVT we know that there must be a maximum and a minimum over this closed interval. Now let's look at another example. If we have the function f of x is 1 over x minus 5, what does EVT tell us? EVT does not apply. F of x is not continuous over the closed interval 0 to 10, because when x equals 5, the function is undefined.
The next theorem is the intermediate value theorem, or the IVT. Let f of x be continuous and closed between the interval a, b. And let y be any number between f of a and f of b. The IVT dictates that for some input, the value c, within a and b, f of c equals y such that y is greater than f of a and less than f of b. Let's look at a graphical example. Here we have the continuous graph f of x, and I've labeled the points f of a and f of b as outputs, and here we have labeled the point y as an output. Due to the IVT, we know that there must be some value c for which f of c equals y, because y is in between f of a and f of b.
Now let's check out an example of IVT. If we have the function f of x equals x times the square root of x, which is obviously continuous over the closed and bound interval 0 to 4, f of 0 equals 0 and f of 4 equals 8. This means that according to the intermediate value theorem, there must be a value c for which the output is between f of 0 and f of 4, because those are the endpoints of the interval.
Our last theorem is the mean value theorem, or MVT. When f is continuous on the interval a to b and differentiable on the interval a to b, then there must be some value c between a and b such that f prime of c is equal to f of b minus f of a over b minus a. This theorem is probably the most complicated, so let's look at a graph. Here we have f of x, which is closed and continuous and differentiable on the interval between a and b. Now to make this simple, let's find out what f of b minus f of a over b minus a is. Really, it's the slope formula. MVT dictates that there must be some point c on this graph, such that f prime of c is equal to the slope of the line passing through points a and b.
Now let's try an example for MVT. Let's say that f of x is equal to x plus 4 over 2. This function is continuous and differentiable. It occurs over the closed and bound interval 1 to 5. We can assume that 1 and 5 are the a and b values. By the mean value theorem, we know that a point must exist between 1 and 5. This point must exist where f of b minus f of a over b minus a is equal to f prime of c.